Hello, everyone. On behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. My name is Janine Donnelly. I'm the Manager of Webinars for IBM Systems Magazine, and I will be the moderator for today's event. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources on the left side of your screen. Today's webinar, 2018 RMF SMF Analytics, Status and Predictions, is sponsored by IntelliMagic. Our featured speakers today are Brent Phillips and Todd Habakost. Brent is Managing Director of IntelliMagic in the Americas. He's worked with mainframes for over 30 years, starting in operations, mounting tapes in university, onto systems programming, and then to designing, developing, and supporting software for mainframe environments. Todd is a Senior ZOS Performance Consultant with IntelliMagic. He has 40 years of IT experience with a primary focus on ZOS systems performance. He joined IntelliMagic last year after experiencing firsthand as a customer the visibility IntelliMagic Vision provides into Z Systems Infrastructure. So 2018 is a watershed year for how RMF and SMF data is used by performance and capacity teams. Today, Brent and Todd will discuss the smarter analytics trends that are currently taking root in the mainstream. With our introductions complete, Brent, I'll turn the presentation over to you.
Great. Thank you very much, Janine. Welcome, everybody. Thank you for joining us. This is a topic that has a lot of interest. I think it's actually the largest webinar in our history in terms of the number of people that have registered. So it's a good topic, and glad you can join us today. As Janine said, and you saw in the advertisement, I guess, for the webinar, the topic is about, from our perspective, the availability of the ZOS application infrastructure. And in particular, what are some things going on about adding more intelligence to the process that will help the performance and capacity planning operations. So we'll discuss in this artificial intelligence, and in the job and skills gap basically in this area, how that affects that. Then we'll get into content more about what do we mean by application infrastructure availability, how does artificial intelligence and machine learning play into the changes that are going on in this area, and in particular, how can we make the whole process more predictive, more preventive, and more prescriptive through more intelligence out of the data. And in this section, Todd will have a role by showing some examples in a demonstration. And then after that, we'll touch briefly on some new uses for the data that are enabled when you process it using more built-in intelligence to the process, particularly for application owners, for DevOps processes, and for outsourced sites. So due to the amount of content, we've had to cut out some of those, some of the details in that portion, but we'll provide some additional references for more information if those are areas of interest for you. So part of this content is about predicting, what's different on where we're at here at the beginning of 2018 than it's been in previous years. So here's a single slide summary of the different areas. First of all, we'll talk about what's near and dear to most of your hearts probably on how some perspectives regarding the AI and machine learning and how it can impact your job. And then we'll get into more details about artificial intelligence and kind of cutting through all the hype. I think every vendor in the world that does anything with analysis products is saying a lot of the similar things on their websites about their products. But we need more clarity about what this really means. And first of all, what's the status of it? And is it mainstream to modernize using artificial intelligence on the RMF and SMF data? And then kind of focusing in on the intelligence and insight that's really derived from the data. How different is the result? how do we know what the data means from a performance and capacity planning perspective? Then we'll get into some specific problems, and this is the area that the demonstration will be focused on to help differentiate the hype versus the reality on how can it really change the processes in the performance and capacity planning areas. And then at the end, like we said, we'll touch briefly on some new applications for it. So first of all, just it might be of interest to some people on where our perspective is coming from at IntelliMagic. We like this quote from 1962 about how technology can be difficult to differentiate from magic when it first really is a game changer in a certain area. And of course, from our company name, you can tell intelligence is quite important to us. We've been focused on this for, well, since 2003 was the genesis of the IntelliMagic name for the company. Our roots actually go back to the early 90s when we started doing performance modeling for mainframe disk storage and expanded on from there to monitoring solutions and modeling in a variety of areas. So we've got a lot of experience over the 13 years that I've been with IntelliMagic. I've talked to a lot of different mainframe shops in the Americas regions, and this is really the basis for this presentation on what we see happening in this particular area. So first of all, about the job. I mean, it's in the press a lot about AI replacing certain kinds of jobs. What's the impact for performance and capacity planning jobs? So there's two answers, as you can probably discern from the answer one there at the beginning. The first answer is no. Your job is more likely to be replaced by outsourcing, actually, if you don't adopt what you might call real artificial intelligence in the data analysis process. And I know that sounds kind of odd to say real artificial together, but obviously there's some artificial intelligence that's more about hype than it is about substance regarding what it actually delivers in terms of understanding the performance of your ZOS infrastructure and preventing problems, resolving problems more quickly. So one of the reasons why I say this is that there's really bigger than ever demands and expectations for performance and capacity teams. And this infrastructure has increased in scope for most organizations, just in terms of how many transactions you're processing, the size of the infrastructure. The complexity of it is increasing with additional capabilities, whether it's pervasive encryption or compression or a lot of different features that have new metrics and new components. And there's just more dynamic workloads than there used to be 5 years ago or so, with 24/7 access from mobile phones. There's a lot of pressure on organizations regarding the application development to make them more agile. So you may be having some key applications that are getting a new release every month or maybe even more frequently, and maybe not fully tested from a performance perspective. So there's more demands, while simultaneously there's a smaller than ever pool of deep expertise. The performance and capacity planning skills gap is real, especially it seems to have accelerated over the last 12 months. I'm familiar with many sites that have some deep experts that are really are retiring, and it's difficult to bring new people up to speed quick enough. So it's a unique area. In the mainframe, a lot of people are very familiar with the mainframe skills gap, but it's one thing to retrain a programmer to program in COBOL, for example, and it's a completely different thing to bring somebody new into the performance and capacity team and expect them to quickly gain speed on all of the different aspects of the infrastructure. So we have a 1-hour recorded webinar on this topic. If this is an area of interest for you, I would suggest you click on this link. You'll be able to do that in the PDF of the slides if you want to download those. And then finally, there's additional pressure on financial executives about controlling costs and risk and focus. And this also enters into the equation about whether we can really replace what we're doing today on the platform. However, there are certain tasks. So while I'm not aware of a single site that's completely replaced, there are existing processes that they've been using to report on the data for over 30 years now. Certainly there are parts of the job that have been replaced. And it's the areas that, even some of them that require specialized expertise to accomplish. For example, manipulating the data, preparing it, or correlating data, managing the performance database. Maybe I'm aware of some people that focus a lot of hours on building certain spreadsheets manually and custom coding reports for each new view that's desired. And especially this idea of looking at the reports to try to spot problems in the reports. So this is such a big task actually, because there's probably should say thousands of static reports, because that's kind of a catalog of static reports that most people are using to understand the infrastructure and the performance on an application by application basis, or the overall infrastructure performance itself. So people just don't have enough time to do this already, and it's typically only, you dive into this when a particular production problem is already occurring. But that process of finding out what they mean, a lot of that actually can be automated. And that releases current staff to focus on higher value kind of tasks and actually resolving the risk and the problems and seeing inefficiency, making some changes in the system to reduce MLC costs, for example. We have a lot of interesting examples of that kind of activity as well, when the right intelligence is made very accessible to the staff. And that's this idea of using some AI-derived intelligence about what the data really means. It should become an easier process to understand what the data means, and the computer can help with that. Because the overall objective of the performance and capacity team is really the nonstop delivery of sufficient application availability in an efficient way. A lot of people think of the word availability as very binary, like, okay, we've got 999s or 49s regarding the status of ZOS. It just doesn't go down. But we view availability as more on the application level. Can the infrastructure deliver the service levels for the application so that the users of the application are not slowed down or transactions don't fail, these kind of things. So if you look at availability from that perspective, it's much different than the binary, 999 kind of uptime thing. It's more about performance. Most of the problems with applications come from performance issues. Of course, it's not the disaster recovery kind of scenarios where a primary data center takes a hit from natural disaster or whatever, and you have to swap over to a secondary site. This is protecting the continuous availability status of the primary production applications. And the computer just needs to do more of the work to help the humans on the performance and capacity team in order to make this a more effective and efficient process. So when you look at really what has to be done, it becomes more clear. Most sites are on a 15-minute RMF or SMF interval, which means 96 sets of RMF data today. Every single LPAR in the environment has thousands of related devices and ports and coupling facility structures and so on and so forth. And each of those particular items or devices typically has from 5 to 50 different metrics. There's some that provide logical views. There's some that are more related to the physical infrastructure, and you really need to build the right picture of what's going on. You have to correlate those together and consolidate different counters, normalize the data, these kind of things. So to really understand and proactively monitor the performance for the infrastructure, you're talking about tens of millions of interrelated metric values. So it's pretty difficult to get your head around all of that and continuously monitor that, especially in the light of what are the ZOS best practices for this part of the infrastructure. And is there risk in the infrastructure for delivering this continuous availability for different applications that are using those shared resources in the ZOS infrastructure? So there's best practices involved. There's specific workload patterns. How have they been changing? How are they stressing the components? Is there any loss of redundancy? The OS is really quite good at maintaining availability even when certain redundant links have dropped, but it's pretty important from a risk perspective to very quickly identify when that happens, and different cost efficiency and error issues as well. So you can have 4 monitors like this guy here, but still it's obviously, even for a very competent person, too much data to really proactively review and understand. So even if you had a whole army of people here, it's just so much work. It's not feasible, and of course, no organization is going to spend that much on that many headcounts to do it. And even if they did, it's pretty boring to continually assess all of the metrics against these best practices and capabilities of the hardware when 99% of the time it's within range. So it takes a lot of deep expertise, but it's a very manual and tedious process to make those kind of comparisons, and that's not what the deep experts like to do. So it's pretty obvious, I think, to most people that manual tasks can be replaced, and indeed they will be replaced, just as they have in many other industries, such as the picture shown. Nobody is doing that kind of job anymore. But in essence, it's good. It allows us to focus on more impactful results for the organization to achieve and carry out our mission more efficiently. And it really increases the value of the staff that's emphasizing that type of work. And from my perspective, I have talked to a lot of mainframe shops across the country, and I'm not aware of any performance or capacity staff reductions that's due to the AI automation kind of tasks that are coming, or capabilities that are coming online. It's more to an outsourcing kind of issue where the changes happen. So one of the stories I like is about Milton Friedman, an economist back in the 60s, when he was taken to a foreign country and shown this project to build a canal, and they were all using shovels, and he asked, why aren't you using earth-moving equipment instead? And they told him, well, it's a jobs program. And his famous quote on the subject is, well, if it's jobs you want, why not give them spoons instead of shovels? And the point is, there's different ways to accomplish a task. Some are more efficient than others. And in the mainframe world, we're not trying to create jobs, obviously. It's the opposite. In our competitive world today, I mean, the backhoe is going to win over the shovel every time. And in fact, you have to automate in order to remain competitive. So in conclusion on this particular section, is it going to replace your job? Well, RMF and SMF is a very rich data source. And all the computing platforms in your data centers, it probably generates the most robust metrics, which means the analytics on it can be smarter if you're using smart algorithms to really mine that data and help you understand what it means. So it's an area that's ripe for automated assessment or interpretation to be able to understand more easily what the data means from a performance and capacity planning perspective. However, most sites are still using this shovel era kind of technology with generating a catalog of static reports that somebody has to look at with different areas of expertise and figure out, is this good or bad for our workloads on this specific portion of the infrastructure. So in this whole area of modernizing, you don't need a new reporting tool for the data, because you already have more reports than anybody has time to look at. What's most important is how do you interpret the data and what it means. So this is all about better intelligence. And the employing AI as what you might consider a force multiplier is inevitable. Once the technology is proven for people and you're convinced of its capabilities, then it's going to be put into place. The computer has to do more work just because of the nature of the job. So from our perspective, it's not human versus machine, but it's human and machine versus problem. And actually, there's a lot of things about the process of identifying problems and resolving them and actually proactively preventing them before they hit a production status can be significantly improved, because we're using a pretty antiquated process to understand what the data means. So here's the prediction for 2018. It's This is what we see happening through our discussions with clients around the country over the last year or so, and I think we're at the point where it's pretty generally accepted that inviting artificial intelligence to the performance and capacity team is really necessary in order to remain effective and competitive based on other things going on with other computing platforms and other organizations and how they're deploying this kind of technology. So let's move over to some of the things that will create more clarity through this AI hype that everybody's talking about. First of all, the question is, what is AI? When we're talking about, is this going to be mainstream, or is it already for RMF and SMF? And here's a definition I like. It's very simple. From 1968, is simply the science of making the machine do things that would require intelligence if the humans have done that. I guess it's 1968. I should have said humans or men and women. But you get the idea. So what kind of things are we talking about? First of all, I mean, we've been automating things in the mainframe platform for many, many years. And there's more in the process that can be automated just from a kind of a logistical perspective. But even more important than that are these kind of things like continually assessing and rating all of the metrics and seeing what kind of violation of the proper health condition or best practice or capability of the components, how severe is the violation of that, of our data, so somebody can then know where to focus on and what to do. So everybody in our world knows about IBM Red Books. There's a lot of them out there. It contains a lot of great insight and information about how you would manage different components, DB2 or whatever it may be, for to maintain continuous availability, to maintain proper performance and service levels for the application. So if all of this kind of expert knowledge was in a machine-readable format and the metrics could be assessed against that kind of knowledge, it really is what will take it to a different level. And that's been our kind of focus with what we do here at IntelliMagic. A more detailed definition of AI, you can search for yourself the periodic table of AI. I think that's a good representation of segmentation of what can be considered artificial intelligence. And one of the most common things people talk about these days is machine learning. So machine learning is a subset of artificial intelligence. And it's this idea of enabling a system to automatically learn and improve from its experience without being explicitly programmed. The learning stores this knowledge into models that are continuously improved. And this is an important issue to talk about when we're considering modernization of the RMF and SMF analytics and interpretation of the data. So it's important to define it, and we'll talk about it here on some following slides. But is it mainstream today? Again, there's two answers. The first one is no. I mean, most of the solutions that are considered a modern approach to processing the machine-generated data, like Splunk or ElasticStack or Spark, so far they're unable to displace any of the antiquated RMF and SMF reporting processes. I'm not aware of a single site that has done this yet, been able to replace it. And why is that the case? Well, typically when you just putting the data into that kind of repository doesn't really get you to the objective that we've been talking about being able to be predictive, to prevent issues, or to be able to be prescriptive, mostly because the easiest way to use the data once it's in there is to look at some symptoms of problems. So there is some value in that on recognizing problems that are already occurring, but it doesn't really get to those root issues because it doesn't understand those root causes of the problem. There's no context of the ZOS infrastructure. So it's not predictive or even prescriptive for resolving problems in what we've seen. Machine learning has, one of the benefits of it is that it can ingest vendor agnostic data. But a consequence of that is it has no knowledge of the underlying infrastructure. So for example, a common information model, a SIM for ZOS, is missing in Splunk. So just the process of normalizing the data records in the fields and the counters is more problematic. And it means you have to create a report for every new metric that you want to understand, and you've got to do it from scratch. And I say, here we go again. That means, okay, we've already been there and done that. That's with SAS is where most of us started. on this 30 years ago, and then MXG came along with all these templates that really helps create these so you don't have to do it all from scratch. Well, we're not even that far along in really understanding the ZOS, RMF, and SMF data from a performance perspective compared to what's available on the existing solutions. And even beyond that, it's not just a matter of getting the data in there so it's properly formatted and the reports can be created, but then it's comparing it to this expert knowledge as what we've been saying. That's also missing, and that's really what's necessary to take it to the next level. So on answer 2, though, there is some cases where some of the largest shops in the world that we know of, because they're our customers, they've displaced most or all of their antiquated reporting solutions. So the real difference here is in answer 1 is focused on machine learning. Answer 2 is focused on other types of artificial intelligence. And that's really the key, is how do we get the computer to help make decisions, to interpret the data, and show what it means for performance, availability, and efficiency. To what degree does the metric in question show a good or a bad value in the context of the application workloads and in the context of the capabilities of the infrastructure components that are running and delivering those service levels. So that goes far beyond just correlating symptoms and detecting is there a problem or not occurring. So the prediction here is that this is really going to be an issue that helps bring clarity to people. So a lot of people are exploring these kinds of more modern approaches to understanding the data, but they're going to realize we need additional artificial intelligence approaches to really be able to use it from a performance and capacity planning perspective. That doesn't mean that there's not valid uses for other areas like security event correlation, for example, or even a cross-platform application. Yeah, okay, so let's move on to how do you derive intelligence and insight? There is an absolute truth about the infrastructure and its capabilities. So if you only take a relative perspective on the metrics, one to another, you can detect changes in the metrics, but you don't really know what they mean. Does that change represent more stress on different infrastructure components? You really need to understand the absolute truth about the capabilities of the infrastructure and subsystems in order to understand that. So a lot of people have used GPS as an analogy for different kinds of reporting or intelligence. So I hate to use an overused analogy, but maybe at a little deeper level here to understand that the GPS would never have been adopted if all you could get was your location. So the current location is extremely important, but it's the combination of that together with detailed digitized maps that provides the real magic in being able to map out where you're going, and then even adding real-time traffic information and rerouting to you. And if you think about a machine learning kind of approach to that, how long and painful would it be for machine learning to figure out every road and intersection and store? You don't want to have to discover that. You want that kind of expert knowledge about the physical terrain or the absolute truth of where you're at and where you can go in a vehicle to already be in there so it's very usable. Yeah, so that's required. And just one other point on this I think that's important is the mission critical nature of the mainframe platform that we're involved in managing for continuous availability. It's a similar thing for an airplane, for example. I mean, you don't want to implement a new optimization algorithm with machine learning to route airplanes in a different way and figure out, okay, this is I have to learn based on airplane crashes, you know, what's good and what's bad. It's too mission critical. And for these mission critical applications, you need this built-in expert knowledge. So how do you get it? Historically, we've used this first way here, experienced human experts. We can make high quality decisions if you have the right expertise. It usually takes multiple experts that have expertise in different parts of the infrastructure, but it's very time consuming to go through all the data points for these experts. And it's expensive and it's not scalable, and we have this skills gap issue. So those are some of the main drivers for looking at alternative ways to derive more intelligence out of the data using computer-based algorithms. So machine learning, what we've talked about there on row 2, I mean, it's got some benefits for certain kinds of applications, especially for detecting changes and trends using statistical analysis, but not being able to understand the root causes doesn't really get you to the point of resolving problems more quickly. You would then jump over to your other kinds of tools to discover with the human experts what's going on. And you can't actually predict or quantify the risk of problems happen next week, which is an issue. So from our perspective, what we focused on for many years now is making this expert knowledge in a machine-readable format so that the algorithms can access them instead of the machine learning models. It's in a different kind of model that we have and assess and rate the metrics according to this many robust deep rules that are included there. So from our perspective, we've been talking about this for many years, and I feel that this is a year where this kind of thing is going to help provide some clarity on what's necessary, the ZOS specific knowledge, in order to really define what the data means and deliver more insight. So I was talking to one of my European colleagues just this morning, actually, that was meeting with a site that has spent 2 years now on a Splunk implementation for performance and capacity planning perspective. And when they were able to see all of the insights that we deliver with this approach, it was very clear that it's an extreme difference in terms of how practically you can understand the problems and what the data means and to maintain performance. So, okay, before the demo, there's one other area just to talk about the kinds of answers that when you implement this kind of approach, how can it change things? So this is a quote I like from Kevin Kelly. If you think about just Google or Siri on your phone, his point is that answers are becoming a commodity. You can ask Google whatever you want to know, and it spits out the information that you asked for right away, hopefully, if you made the query right. And that's kind of where we're getting in this whole area of AI-driven analysis of the data. The real intelligence is going to be in asking the right questions and then using the results in a practical way. But that does require this machine-readable, deep expert knowledge in order to really get the answers from a detailed performance and capacity planning perspective. So if you look at a timeline and when a problem occurs, a lot of people are just using the data, the historical RMF and SMF data now to do in a more of a post-mortem kind of fashion to try to figure out what went wrong so we can hopefully avoid this next time and keep a closer eye on it. And so that's good, but it's a better and higher value kind of answer if you understand what's going wrong right now. What are the components that are involved and what levels are stressed or what best practices are in violation. And then, of course, the best is to truly be predictive. This is our definition of what it means to predictive, not finding out about a production problem that's already occurring, but being able to predict what's going to go wrong in another day or week if your workloads increase a little bit, because there's an absolute truth about what different components are capable of, how much throughput through a storage array port on the front end of that box, what are they capable of without introducing delays, for example. So this really can enable a new gap to be filled. On the left-hand side, historically, performance teams have been focused on fighting fires, real time, with a focus on minutes, what's going on right now. On the right-hand side of the spectrum, it's a long-term focus, more in terms of months. And really, to be predictive, it's this central area when the computer does more work and more of the evaluation, delivering more intelligence using what you might call lead measures instead of leg measures. You can really understand what's about to happen and take proactive action to resolve the issue before it's a production problem. The nice thing about RMF and SMF data, it's historical, so if you've had incidents in the past, you can actually process that with this automated assessment of the data to prove what you would have been seeing in terms of a true predictive early warning prior to that incident. And it's the vast majority of cases, there are predictive signals. It's just nobody's had the time to go and review those to be able to catch it in time. And it gets to this idea of the ITIL version 3 definition of capacity management, which talks about considering all resources, meaning every part of the infrastructure that's involved in delivering service levels for an application, Well, that's far more granular than most sites do. They tend to do capacity planning on a long-term basis, on a box level, not on a component-by-component basis. The only way to do that is to automate that granular capacity management kind of process, evaluating the characteristics and capabilities against the metrics on a continuous basis. So just a very quick example in storage arrays, and then I'll turn it over to Todd shortly here for a demo. But this is a great example of leg measures versus lead measure. If you're only triggering on some very simple rules about is the response time too high or not, there's a lot of issues with that, from false positives to false negatives if your alerts are too tight and you miss things that really somebody needs to know. Well, there are this absolute truth we're talking about on the back end, that if you understand the architecture and the capabilities, you can absolutely monitor from an automated computerized perspective those issues so that you can learn about them more quickly. And then even on the back end, the balance within an array or between arrays, or monitoring automatically for changes in configuration, that can provide a significant value in becoming more predictive. And it really can't be done by anybody unless it's automated to continuously monitor those kind of things. So what kind of answers can these solutions provide when they're really driven by AI? Well, specific real-world challenges are what can distinguish the capabilities. And this is what's happening in other non-mainframe areas, like the game of Go in 2016. There was a challenge there of the computer versus the world's expert, and the computer won. I mean, the algorithms are to the point for that particular application where it's better than humans. And so that's the way really to detect, can we assist the humans on the team on identifying areas to the satisfaction of the experts on the team. Well, those kind of tests are not that difficult to run on specific problems in your environment, so especially with the historical data like I was talking about. And just the ability to flag different issues. You'll see these kind of charts in the demo briefly, where, I mean, this is 569 different metrics. This is just a subset of the infrastructure, actually. And very quickly at a glance saying, is there parts of this environment where the best practices are not being adhered to? So somebody knows what to click on, and then drill down and understand why is it rated this way, and what's the remediation. So this kind of process of using specific performance problem use cases is going to help distinguish what's hype and what can really change the game in terms of a predictive, preventive, and prescriptive point of view. So with that, let's switch over to Todd on the live demo and give you some practical examples of what this might look like.
All right, thank you, Brent. So this slide catalogs the breadth of ZOS infrastructure areas that are currently covered by IntelliMagic Vision. And effective performance management involves having numerous functions in place for each of these data types. Today, we commonly encounter sites relying on in-house developed reporting that have fallen behind in their analytical capabilities, particularly in the areas in the emerging column, like ZDC hardware compression and processor cache. So let's use ZDC as an example. It's a technology that's experiencing rapid adoption among our customers. So if you're going to develop your own effective ZDC reporting solution, you need to analyze each of the 80-plus metrics present in the RMF 74.9 records to determine which metrics warrant top-level attention. You need to determine exception values for those metrics that may indicate current or pending risks to availability. You need to create a mechanism to identify when those exceptions occur that would generate some investigation, and you need to develop the reporting that supports lower-level analysis when that may be required. Now, we should note that many of these capabilities are rarely found in the in-house developed catalogs of static reports that are widely used today. Or, as Brent has been talking about, you can let the computer do the heavy lifting for you and leverage the built-in intelligence provided by IntelliMagic Vision. This dashboard identifies a handful of key ZDC metrics that warrant top-level attention, and it assesses the data to identify good and bad values. and then also provides context-sensitive drill downs when additional analysis is required. So in this example, high hardware accelerator or compression card queue times are being experienced, so let's explore those. We'll drill down into this exception by system and see that it's primarily occurring on this particular system here. And so we'll drill into that and generate a set of time charts for all of the metrics that are on that dashboard. And so we can see at a glance here that almost all the activity on this compression card is decompression activity, and that it's very spiky. So let's select this queue time and do some further analysis. And one frequent aspect of performance analysis is seeking to identify potential correlations between various metrics. And this is greatly facilitated by the capability in IntelliMagic Vision to combine on a single chart any variables from this set of hardware accelerator metrics. So let's customize this chart and add the variable for decompression requests, which as we saw on the time charts was the primary activity that's occurring here. And since it's got a different unit of measure, we'll add that on the second axis. Now that task took a few seconds here. It would likely require hours coding a new report for someone that's working from a catalog of static reports. So here we can see that when the activity is high, the queue time is minimal. So that quickly confirms that queue time, this queue time is not an issue that requires additional investigation. Now, on the subject of ZDC hardware compression, the first question that you're likely to get from management is, well, what's our compression ratio? So in this environment, the compression ratio is typically running in the 6-to-1 range or slightly better. But there was an interval here in this time frame where it dipped down close to 1. So we can drill into that by system and see that the activity on this system, this A5 system, was responsible for dragging the compression ratio down. Now, another powerful capability that facilitates effective analysis is the ability to integrate data from separate SMF record types. And this is also a particularly powerful example of the highly flexible drill down capabilities of IntelliMagic Vision, where system-level compression data from the 74.9 records is being integrated with address space data from the SMF 30 records to provide very actionable insights. So when we drill down here to see what jobs were running at this particular time when the compression ratio was so low, we can see that one job was the dominant user of compression at that time, generating over 700,000 decompression and compression requests, with compression and decompression ratio just slightly better than 1. So now an informed decision can be made whether the data being accessed by that job warrants being compressed, an insight that was made possible by integrating data from separate SMF records. And again, this capability to integrate data from separate SMF record types is rarely found in the in-house developed catalogs of static reports that are widely used today. Now, having spent the bulk of 2 decades as a ZOS performance analyst, prior to using IntelliMagic Vision, I always felt that I was operating in reactive mode on performance problems. When I was relying on an in-house developed catalog of static reports, I didn't have the visibility that would enable me to proactively identify and address potential risks to availability in my areas of responsibility. So I'm going to use some MQ dashboards here to illustrate how IntelliMagic Vision enables an analyst to proactively identify potential risks to availability. Now, recent presentations at technical conferences have identified a half dozen or so MQ metrics from the SMF 115 records that attendees were encouraged to manually check in their environments. And judging by the reactions of most attendees in those sessions, they currently did not have that visibility. For users of IntelliMagic Vision, the MQ Buffer Manager and Log Manager dashboards alone are automatically and regularly checking 16 metrics across all the MQ subsystems in their environment. So I'm going to come back to this dashboard in a moment. But first, I just want to point out this exception table, which collects all in one view, all of the exceptions from all of the MQ dashboards, and shows which subsystem, what's the nature of the exception, gives a numeric rating on a scale of 0 to 3, and classifies it as red or yellow when it's an exception. And so here there's a hyperlink to the actual time chart that reflects this metric. So we can go right there, and this is by buffer pool. So we can see that it's buffer pools 1 and 2 for this MQ subsystem that are frequently encountering exceptions, which is a value at the threshold here is set at 80%, which is the value at which MQ version 8 begins asynchronously destaging buffers from memory to disk. Now, the thresholds for any dashboard can be customized if warranted by unique considerations in your environment. All right, so let's go back to that dashboard now. So this presents metrics that can reflect inefficient behavior in buffer pools, which when severe, MQ buffer shortages can result in performance issues impacting availability, and we've definitely seen that in customer data. So I'm going to scroll down here to one of these subsystems near the bottom that has several exceptions, and drill in and look at this, generate a dashboard by buffer pool. So we can see here for this subsystem that it's buffer pools 1 and 2 that are generating the exceptions, which as we saw in that previous chart. So let's drill down on buffer pool 2 and again generate the set of time charts reflecting all the metrics on that dashboard. So we see here this is one of the exceptions. The deferred write threshold is being reached, which indicates that asynchronous destaging of buffers to disk is occurring, which typically represents reaching a given threshold of available pages, which is MQ version dependent. Now, another capability that's comes in very handy for performance analysts is to be able to quickly identify whether this behavior represents an anomaly or a frequently occurring pattern. So IntelliMagic Vision with one click provides the capability to easily compare the current interval against another interval, such as the previous day or previous week or any data in the database, to see if this is a common behavior or an anomaly. And here we can see that yes, this is occurring on each of these intervals. And there's also the capability, don't have time to go into it, but the capability to also kind of look at the behavior over the past month from a time of day point of view, and also see the averages by day of week. Now, having good visibility into RMF and SMF data is essential not only for proactive insights to ensure availability and performance, but also to identify opportunities for more efficient operation of their mainframe environment. And two areas that we could go into there would be processor cache and the work that's running during peak 4-hour rolling average periods, and also providing enhanced SCRT reporting to identify more than just the peak that the SCRT report identifies. But for time, we won't be able to get into those today. So I'm going to just wrap up my portion of the webinar with a couple of observations. First, I'm not aware of any other primary IT operations discipline today where companies invest significant resources trying to develop and maintain their own processing solution versus acquiring well-designed off-the-shelf functionality that's supported across a broad customer base. You know, you don't expend your scarce technical skills writing your own job scheduling system or developing a homegrown real-time monitor, and you don't accept the capability limitations that are inherent in a solution that are developed by in-house resources doing this work on the side. But yet we repeatedly encounter sites today who are trying to deliver world-class availability and performance, relying on their own in-house developed catalog of static reports and their own exception detection capabilities, which are often implemented in reactive mode only after experiencing an outage, and often also only deal with the symptoms and not the root causes. So no matter how skilled any team is, it's unreasonable to expect in-house solutions developed by that team moonlighting in this role while they're doing their primary performance jobs can provide the proactive insights that are needed to deliver the high levels of availability that are required across the breadth of infrastructure in today's complex mainframe environments. In-house solutions aren't capable of delivering the level of effective performance management provided by a well-designed product developed by a larger team of people funded by having many customers, particularly in areas like user interface flexibility, drill-down capabilities, visualization, and data integration. And then finally, over the past 2 years since I've joined IntelliMagic, I've had the opportunity to review SMF and RMF data now from more than 50 sites. Leveraging IntelliMagic Vision, I've been able to quickly gain a working knowledge of these environments that has enabled me to come in as an outsider and have very substantive dialogues across the wide scope of performance issues being faced by technical teams who have years of experience in their own environments. And in a significant majority of the cases, these discussions have identified performance and/or efficiency opportunities in their environments that they were previously not aware of. And that's possible because I am able to utilize technology that does the heavy lifting, that leverages built-in ZOS-specific expert knowledge. It programmatically assesses and rates hundreds of metrics across the thousands of elements in their ZOS infrastructure, and which provides unparalleled visibility into the rich SMF and RMF data generated by the mainframe platform through context-sensitive drill downs and other capabilities that you saw demonstrated today. There's no way I could rapidly identify helpful insights for environments as an outsider if I had to sift through catalogs of hundreds of in-house developed static reports. So if I as an outsider can reach this level of insight in just a few hours, imagine the effectiveness and productivity you and your teams could develop in your environments with IntelliMagic on your team, unleashing its capability of identifying issues that are beginning to develop so that you can address them before they turn into outages, providing unparalleled visibility into your SMF and RMF data and deriving unparalleled value from that data, and freeing you up to focus on high-level analysis and the proactive actions that will protect and preserve availability for your systems. All right, Brent, I'm going to hand it back to you.
Okay, very good. Thank you, Todd. I know we have a lot of technical people on the webinar today, and we felt that some really practical, real-world examples would be useful for you. So hopefully you're seeing my screen again. Yeah, it's difficult to assess when you see a dashboard with green, yellow, red. Lots of people have been doing that kind of thing for a long time, but I hope that a couple of the detailed scenarios that Todd went through can illustrate the underlying work that's being done by the computer to look at MQ, for example, and flag this buffer pool problem automatically without anybody having to go and look at the reports. So there's exception tables, there's alerting, so on and so forth. And one point I do want to make is that while, to duplicate this kind of thing, writing your own reports in one of these modernized solutions we mentioned would take, just years of work, essentially. There is value in putting the intelligence into an environment like Splunk, for example, especially like for cross-platform applications. And so it's not really an either-or situation from our perspective. We have the ability to export the results of these assessments over to Splunk, and so it's working in tandem. But if you have an expectation to replace what you've been doing for 30 years without this kind of deep understanding of the environment, it's just not going to be met anytime soon with a manual kind of approach to these newer kinds of products. We have a few minutes left, and please do submit questions. If you have some, we won't have time on this session to answer them live, but we will get back to everybody that posts a question to us. I just want to talk briefly about this topic here on enabling new types of uses for the data. So again, we have a 1-hour webinar recorded on this subject. It's a huge problem for almost every organization that I know of on understanding the ramifications from a performance perspective of new applications on the infrastructure. APM, application performance monitoring, is its own discipline, but it does not take into account the performance of the infrastructure. And pretty much everybody on the call is probably aware of an instance when a new version has been loaded. changed the performance profile, and it wasn't properly tested. Well, these features that Todd was talking about, like the compare function, for example, and we have another feature that we haven't had time to go into on application grouping, where you take, you can segment all the workloads for a particular application that's running on the shared infrastructure resources, and then create a report set of the different components with this compare function turned on, which automatically calculates the variance between these areas. And so if you're running test workloads on the production application and on the version that's in test, it's a way to quickly identify in an automated fashion, is there a difference in the performance profile or the performance signature from an infrastructure perspective of that new version compared to the previous version. So that's what that webinar covers, and it's an interesting new application that gets more value out of the RMS and SMF data than organizations are doing today. There's also the idea of creating a application health dashboard from an infrastructure perspective that the business owners, application owners would be interested in. And of course, those are the profit centers of the organization, those applications and what they generate. So that's also an interesting topic. And finally, just validating, a lot of sites are outsourced or contemplating that. And there's some significant issues in that kind of setup that we'll address in an upcoming webinar. But the idea of validating the outsourcer services, and both from a performance perspective and basically proving whether SLAs are met or not met, and also from a cost efficiency perspective, there's a lot of value in taking this kind of approach with the analytics for that kind of environment. So these uses of data can actually accelerate the modernization project from an IT executive standpoint. Both IT ops advances in that area, doing it in a more automated fashion in terms of data interpretation, but these new areas can help justify those projects. So you'll get a copy of the deck if you want it. Here's all of the predictions in one place. Let me just quickly summarize key takeaways. Only engage in this kind of modernization projects if it's really going to be able to update the 30-year-old process that everybody was typically using, whether that's a SAS and MXG kind of process, or there's a lot of reporting products out there that essentially are doing the same thing for you, but it's a catalog of static reports without this built-in intelligence and without the ability to drill down and correlate metrics together and the physical and logical views and so on and so forth. So that's what's going to make it a game changer when you start this kind of project. And what matters most is what the data means, deriving intelligence from the data and engaging in specific problem challenges like an MQ problem that Todd talked about, or maybe it's processor efficiency, or a whole slew of those kind of problems. Can the new technology really understand and assess and rate those issues from a predictive point of view, from a root cause analysis to help in resolving those kind of issues? That's kind of the acid test of whether this project is worthwhile or not, whether it will really modernize the whole process for you. So from our perspective, if you're not outsourcing, I mean, this is inevitable to modernize the approach. And the sooner you do, the sooner you'll start to get benefits from it. From our perspective as well, talking to executives around the country, it's fairly easy for them to see the strategic value because they're doing this kind of AI-driven modernization and analytics in other areas of the business and realize it makes sense to do it in the IT operations area as well. It's available via delivery of the cloud as well, at least from IntelliMagic. So really, literally overnight, you can start receiving the intelligence from the data in that fashion. And if you are outsourced, there's significant accountability from a performance and cost perspective that's available with the same process. So finally, I know we're at the top of the hour now, so if you want to see it with your own data, there's a link available on this, or at the top of our website. There's a link as well, so we're happy to assess the data for you and demonstrate this kind of intelligence process on the data. And with that, Janine, I better turn it over to you since we're at the top of the hour.
Hey, thanks, Brent. We are at the top of the hour, so I want to thank everyone for attending today's webinar. I especially want to thank Brent and Todd for sharing their expertise with us today. If you did have a question and you submitted a question, please know that someone will reach out to you via email. Later this week, we'll be sending out a follow-up email with a link to the recording of today's webinar to everyone who registered. That concludes our webinar. Thanks again for joining us, and have a great day.